Hello everyone, welcome to my channel. In this video, we are going to understand about the asymptotic notations and the different types of asymptotic notation, that is big O notation, omega notation and theta notation. Okay, so here, before going to know about the asymptotic notation, let us know about the complexity analysis. That means how can we analyze the complexity of a particular algorithm. First of all, what is a program and the algorithm? What are the difference between the program and algorithm? So we know that a computer is made of a set of programs or a series of instructions arranged in a particular order to perform a task. A computer is nothing but a number of programs to perform a task, and basically we are using the machines to make our daily routines easier, right? So a computer will be having some set of instructions to do a particular task. So the program is written to instruct the computer to perform a specific task in order to obtain a desired result. Okay, so if you want to do a particular task, based on that, some instructions are written and given to the computer. For example, if you take, I want to take a printout of the document. Okay, then I will use the command Control P to print the document. Okay, so based on the instruction, the computer is going to produce the output, that is by producing the printout of the document, right? So in this manner, I am obtaining the desired result, that is the document printout. So irrespective of the language used to develop a program, there are some generic steps that can be followed to solve a problem. So these generic steps are called algorithms. So irrespective of the language to develop a program, there are a number of steps to solve a problem. Okay. So these steps are called algorithms. So here what is a program? So we are having n number of programming languages, right? Like C, C++, Java, Python, and .NET. So we are having number of programming languages. Okay. Suppose I'm taking sum of addition of two numbers. So then I can write this sum of addition of two numbers in any programming language. Like in C language I can write, okay, and C++ I can write, or in Java or .NET. In any language I can write this particular program. So how we are going to write? So first of all we have to declare and define the integers, right? And then we have to give the input to the integers, and then we have to perform the sum of two integers. Okay, so this is the process of solving the sum of two numbers, sum of addition of two numbers. Okay, so this is the set of steps to solve the sum of two numbers. So this is called as an algorithm. So for this particular steps of solving the sum of two numbers, so we can write the program in any language, like in C language or programming or Java language, .NET, PHP, in any of the language you can write the program. Okay. And for example, if you want to, I will take an example like, so if you know bike riding, then you can drive any bike, right? If you know how to drive a bike, and if you are a licensed person, then you can drive any bike. So it may be Activa or any bike, right? So this is a perfect example. So if you know driving, then you can drive any bike. Similarly here, if you can consider that driving the bike as algorithm, and you can apply this algorithm for any programming language. That means you can drive any bike. So it may be of a different model or different companies. Okay. So now let us know about the algorithm. An algorithm is a set of instructions to perform a particular task. So it is considered as a tool that helps to solve a specific computational problem, right? As I told earlier, if you want to write the program for sum of two numbers, then you can write this program in any language. Okay, so what is the process here? So algorithm defines the process of performing a task. So here the task is sum of two numbers. So if you want to perform the sum of two numbers, then you have to first of all declare and define the integers, okay, and then you have to store the address of the integers, and then you have to perform the sum of the integers and store the new result into the variables, right? So this is the process. So this is the algorithm. So based on this algorithm you can write the program in any of the language based on the syntax of that particular language. So it is considered as a tool that helps to solve a specific computational problem. So next one is the asymptotic notation. Okay. So here basically we are using the asymptotic notation. The complexity of an algorithm is a function that describes the efficiency of an algorithm in terms of amount of data the algorithm must process. Okay. So here the complexity of an algorithm is a function that describes the efficiency of an algorithm in terms of the amount of data that the algorithm must process. Okay. So here for a particular input size, that is n, okay, so here I am giving the input size n for a particular algorithm, okay, for a particular algorithm. So for the particular size n, the algorithm may work faster. For suppose another type of input, the algorithm may work slower. Okay, so here I am taking the, for sum of two numbers, if you consider, I am taking the I am giving the n input as 3 and 5, 3 plus 5, then the sum will be easier. So 3 plus 5 equals to 8. So this is for example only. Suppose I am giving a larger number like 20,000 or 20,339 like that, plus 3,590 like that. I am giving a small larger number. So the working of the algorithm may get somewhat slower, right? So for the input, so based on the input, the processing, the working of the algorithm will be slower or faster. And similarly here, for a particular input size n, the data structure may also vary. Suppose I am giving an input size n for a data structure stacks, and for the same input I am giving it to the queues. So there will be some difference in the working of the, or the complexity of, or measuring the complexity of the program. Okay. So for the particular input size n, so a data structure may work faster or slower. For the same input size, so another data structure may work faster or slower. Okay. So like this, so based on the input size, the algorithm may work faster or slower. Okay. So there are two main complexity measures of efficiency of an algorithm, that are time complexity and space complexity. Time complexity means it describes the amount of time taken by an algorithm to solve a problem. And space complexity means the memory or space occupied by an algorithm to run. So a good algorithm must have minimum number of space complexity. Okay. So here basically we are considering for the algorithm it must occupy less amount of space and it must execute in less amount of time. Then we will consider that particular algorithm as the best algorithm. Okay. So we can easily measure the efficiency of algorithms by calculating the time complexity. So here we are going through only time complexity, not the space complexity. So we can measure the efficiency of algorithms by calculating the time complexity. The easy way or the approximate way to represent the time complexity is asymptotic notation. Okay. So this is the approximate way of representing the time complexity. So that is called as the asymptotic notation. Okay. Suppose here we are considering some examples for the time complexity. How we will calculate the time complexity? So I am taking the sum, a small algorithm here, sum of a comma n, that is two numbers, and I am first of all initializing s equals to 0 and for loop, and then sum of s plus the a of I, that is the elements in the array. and then returning the sum. Okay, so for this particular program, so here there is we are not calculating the time complexity for the sum, and then so for s equals to 0 we will calculate the time complexity as 1, and for I equals to 1, so it will run n times, right? So for up to 1 to n it will execute. That means this for loop will execute n times, and then the statements inside the for loop will execute one time, and the return statement will execute one time. So totally it will execute n plus 3 amount of time. Okay, but here the time complexity of this particular algorithm is big O of n. So we will see about the big O of n in the next series. So big O of n is the time complexity. So we are going to neglect this constant value. Okay, so that's why we are considering it as asymptotic notation. That means we are taking the approximate value of the particular algorithm. So here n is the approximate value of the algorithm. Okay, so next one. So here I am taking the if else condition. Okay, so in the if else condition, if the given condition gets satisfied, then the particular program will execute only once. That is, it will be having only constant amount of time, that is big O of 1, right? So if this gets satisfied, that is, if the condition gets satisfied, it will execute only one, right? For the return statement. If suppose the condition fails, then it will execute the else statement, and it will execute n amount of time. It will execute n number of times by the recursion. So again it will call itself, again it will execute. Like that it will execute n number of times. So if the else condition gets satisfied, then the time complexity will be big O of n. Right? So next one. So if there are two for loops here, okay, two for loops are there, then how it will get executed? So for a particular for loop, it will execute n number of times, and the inner loop, for the inner loop, it will execute n times. Okay, that means totally n square it will execute, plus the constant time for the statements inside the for loop, that is 1, right? So totally it will execute n square plus 1 amount of time. But we are considering the asymptotic notation for the time complexity, so it will take the approximate value, that is the big O of n square. So here the constant is negligible. Okay. So here we are going to know about the different types of asymptotic notation. So asymptotic notation is used to describe the running time of an algorithm for how much time an algorithm takes with a given value n. Okay. So here we are going to consider the approximate value for a particular n input size. Okay. So how much time an algorithm will take to run, or for a particular input size. Okay. So how the data structure will work. So we are going to apply the same input size for different types of data structures. That means it may be arrays, stacks, or queues. So we will see the three different notations, that is big O, big theta, and big omega. So first of all, we will start with the big O notation. So it represents the upper bound of the running time of an algorithm. Okay, so that means here the upper bound means the worst time. Okay, the maximum time it can run. Okay, suppose a program may take so 1 to n. Okay, sorry. So suppose a program may take 1 millisecond to 10 milliseconds of time. Okay, so a program may take 1 millisecond to 10 milliseconds of time based on the given input. Then what is the worst time taken by the algorithm? Means that is 10 milliseconds only, because it is the worst case or the utmost case that it can take to run right? Similarly here the big O notation means, so the worst time taken by the algorithm to execute, or the upper bound or the utmost time taken to run the algorithm. So here we are considering the f of n equals to big O of g of n. So we can represent the big O notation in this format. Okay, so here f of n is the function or the function that we want to execute here, and big O of g of n. So we can represent the big O of g of n in this format. So f of n must be less than or equals to c into g of n. So here c may be any constant, c may be any non-negative constant. So c and n naught are non-negative constants. So f of n, that means the given input size must be always less than or equal to c into the constant into g of n. Okay, so here f of n is the input function that we are considering. Suppose if you want to execute, you want to satisfy this condition. Okay, so the c constant value must be always greater than the value in the f of n. Suppose, so this is the graph of how we execute this function. Okay, so f of n can execute less than or equals to c into g of n. That means f of n cannot cross the g of n, right? So it can reach only up to g of n only. It cannot cross the g of n. So maximum, the f of n function can maximum execute up to g of n only. Okay, so here n is the input size and the y-axis represents the time. So this is the time and n represents the input size. Okay, so here the f of n function can execute at most, or the worst time is g of n. So up to this only it can execute. Okay, so this is the uppermost bound. And here we have to find the c and n naught. So based on the c and n naught values, that is the constant values, we can consider the g of n value. So here I am taking an example of how we can solve the big O notation. So f of n equals to 3n plus 2 and g of n we are considering as n. So we know that big O notation is represented as big O of g of n. Okay, so f of n is less than or equals to c into g of n. So this is the formula for the big O notation. So we are taking the function that is 3n plus 2 can execute. How it can execute? So 3n plus 2 is less than or equals to c into g of n, and 3n plus 2 is less than or equals to 4n. So why we are taking the 4 here? So g of n value is n I am writing, and 4 we are considering because, so here there is a 3n. Okay, so 3 is less than or equals to 4 only, right? So that's why we are taking the value 3n plus, for the 3n we are taking the 4. So for the notations we have to, the constant value must be always greater than the value in the constant, the higher value in the f of n. So here the higher value in f of n is 3n only, right? So c must be greater than the higher constant value. Okay, so that's why we are considering as 4. So 2 is, so if you substitute this 2n, so 3n minus 4n, that is n, 2 less than or equals to n, and so say n must be always greater than or equals to 2, that is c equals to 4. So here the constant value is equals to 4 and n must be always greater than or equals to 2, right? So next one is the big omega notation. Omega notation represents the lower bound of the running time of an algorithm. Okay, so here the big O means it represents upper bound. So big omega notation represents the lower bound of the running time of an algorithm. It provides the best case complexity of an algorithm. That means it tells us the least amount of time taken to execute an algorithm. Suppose a program can execute 1 milliseconds to 10 milliseconds. Okay, so I'm considering this. So based on the input size, the maximum, so the best case is 1 millisecond and the worst case is 10 milliseconds. Okay, so this is the minimum amount of time taken to execute the program and the maximum amount of time to execute the program, that is the worst case is 10 milliseconds. So it provides the best case of the algorithm. Okay, and lower bound of the running time of the algorithm means it gives us the minimum amount of time taken to run the algorithm. So that we can reference the big omega in this format. F of n equals to big omega of g of n for the non-negative constants c and n naught. Okay, so f of n is always greater than or equals to c into g of n for all n greater than or equals to n naught. So we will consider the graphical format of this. Okay, so here n is the input size and the y-axis is the time. So for the particular n input size, so how the time will increase or decrease. Okay, so the function f of n can execute in the minimum time. So the minimum amount of time it can execute, that can be represented with the big omega notation. So here we have to find the c and n naught, that is the n value is greater than or equals to 1. Okay, so here I am considering the c value as 3 for the same function f of n equals to 3n plus 2. So we are considering 3n plus 2 greater than or equals to c into n. Okay, so 3 is greater than or equals to c is correct, right? So that's why it's greater than or equals to 3 is correct. So the c equals to 3 and n greater than or equals to 1. So next one is the big theta notation. So here theta notation represents the upper and the lower bound of the running time of an algorithm. So big theta notation is going to consider both the upper bound and lower bound of an algorithm. So it is used for analyzing the average case complexity of an algorithm. So in the case of the big O notation we are considering worst case, and here in the big omega notation we are considering the best case. So this is going to consider the average time taken by an algorithm. Okay, so it will consider both the upper bound and the lower bound. So f of n equals to theta of g of n. So if there exists non-negative constants c1, c2 and n naught. So c1 g of n less than or equals to f of n less than or equal to c2 of g of n. Okay, so these are two non-negative constants. Since we are using the f of n less than or equals to c2 g of n represents the upper bound and this will represent the lower bound. Okay, so since we can analyze both the upper bound and lower bound, that is the average case of the algorithm, of the running time of an algorithm, we are considering this condition. So f of n lies between the c1 and c2 only. Okay, so if you consider this example 1 milliseconds, that is the best case, to 10 milliseconds a program can execute based on the input size. If the input size is larger, then it may take 10 milliseconds. If the input size is lower, when it is small, then you can run it in the 1 millisecond. If the program input size is average, that means if it is not bigger or smaller, then it lies between the 1 millisecond to 10 milliseconds, right? So this is the average case of denoting a running time of an algorithm. So let us see an example here, the same example for the f of n function 3n plus 2 and g of n equals to n. So we are writing the formula for this function for the big theta notation and substituting the same values in this formula. So c1 is 3n less than or equal to 3n plus 2. So c2 is 4n. Okay, so here 3 is less than or equals to 4 and 3 is less than or equals to 3. So we have to consider this highest value here. So 3 is less than or equals to 3. So this will get satisfied and c1 equals to 3 and c2 equals to 4 and n naught equals to 2. Right. So if you substitute this formula, then you will get this answer. So this is about how we can write the formula for the theta notation. So basically in the data structures we will be using the big O notation mostly to represent the time complexity of an algorithm. That is the worst case running time of an algorithm. So the next video we will see the remaining concepts and the data structures. Thanks for watching my video. Please like, share and subscribe to my channel. Thank you.